doing DeFi, greatest in the world, and they finally about to see why. What you know about XRD? I'm smart money, I ain't never on a decline. What you know about NFTs? It's not just Ace, when you finally gonna realize you need scalability, need more utility, then you better call on these guys. I'm going radical, I'm going Radix, I'm going radical, I'm going Radix. Hyperspeed DeFi, never on a decline, building the future, I feel like a savage.
Hello and welcome. I am Piers, CEO of RDX Works, a core developer of the decentralized finance protocol Radix, a public ledger entirely focused on bringing DeFi into the mainstream. This is our podcast, The DeFi Download, a show about decentralized finance and all things crypto, where we dive into the details of the projects, assets, and services that are powering the DeFi revolution. Today, I have a special edition of the DeFi Download. I have our very own Matthew Hine, Chief Product Officer of RDX Works, and Mohamed, Head of Research at Alliance DAO, the leading Web3 accelerator in the crypto space. Before joining Alliance DAO, Mohamed co-founded Vault Capital and has been in the crypto space since 2016. Welcome, Mohamed. Thank you so much for coming on the show.
Thanks, Piers, for having me.
And today we're going to be having a very special discussion about a technically deep subject called parallel execution, which Mohamed was, in his function of head of research at Alliance DAO, you were doing a bunch of deep dives into topics, and then you tweeted about this, and some of our community, some of the Radix community found this and were like, hey, you forgot Radix. So we thought it would be good to have a little conversation about parallel execution and dive into the topic a bit more, because I think it's a super interesting topic. So, Mohamed, if you wouldn't mind kicking us off with what is parallel execution, why does it matter, and what are the approaches that people are taking at the moment?
Yeah, for sure, with pleasure. So before we jump into parallel execution, it's like we probably need to set the stage by saying that the most famous and most used blockchain that to run a smart contract, Ethereum, is the opposite of that, right? So like Ethereum is like a single thread processor or a single thread computer in general. And the best way to describe it that like in Ethereum, when you want to execute a transaction, this transaction has to put everyone else, put the whole wallet on hold. Like, stop, I need to finish my execution, I need to finish my Uniswap transaction, and then go to pay back my flash loan or whatever. And when I am done, everyone else can take their turn. So this explicitly explains what is a single thread processor is. And this was a design choice that was made by Ethereum and its community back 2015 when they launched it, because it was the first protocol to tackle this smart contract or like decentralized execution.
It's very simple to start off with. Just sort of assume, oh, okay, everything happens in order. Cool. There's one blockchain, one consensus process. It's simple. Yeah.
Exactly. And it worked well. And it allowed people actually to not worry about parallel execution and who goes first and who goes next and second, and everything is in order. And to some extent, that allowed developers to start writing a smart contract. And we started to see applications like DeFi, AMMs, NFTs, NFT exchanges. All of that happened on Ethereum. But after a while, people, especially in the Ethereum community, say, what? So we have every transaction has to put the whole wallet on hold and everyone has to wait. We need something better. But now Ethereum is already big. There is many contracts running. You cannot just change it, right? So that gives opportunity to other protocols, including Solana, Sui, Aptos, many other Radix, to think about, okay, how can we differentiate? How can we do what Ethereum is doing, but better? Can we increase the throughput? Can we do more transactions by allowing what we call parallel processing? So parallel processing means that instead of every transaction have a unique hold on the wallet, no, we can allow actually independent transactions to run in parallel. What is that? If I'm transacting with Piers and sending him some Ethereum, but Matt is sending some Ethereum to his brother, these two transactions are completely independent, right? So we can, in reality, process these two transactions in the same time, and no conflict happens between them. So the idea in its simplest format is to identify what are the independent transactions. And then once we have this identification, we can move forward simply by asking validators or the network miners to put this transaction, execute these transactions in parallel. And this will allow simply improving the throughput of the network or the transaction per second.
Which sounds really obvious, but it's a pretty dramatic design choice doing that. I mean, it's not what most networks are doing. Like if you've got kind of like, all right, we're trying to get everything through this single pipeline, one thing after another, the obvious thing is if you want to get more stuff through the pipe is like, all right, make a faster pipe, which is what most platforms have been focused on. Is like, all right, how fast can we possibly make that pipe without breaking because it doesn't break all those assumptions. That simplicity of Ethereum, you can keep all that sort of like everything's in order, everything's nice and simple. We just need to make it go really fast. So, the thing you said there about sort of you need to be able to say this thing isn't related to this other thing is a pretty dramatic design choice, because this is exactly what you're saying. It like this now is changing kind of the nature of how things execute, which then becomes incompatible with you when you already have a network that has a bunch of applications running on it.
Yeah, 100%. I totally agree with you, Matt. Like the idea is simple and makes perfect sense, but similar to anything else, once you commit to certain design choices, like Ethereum, when it started, it committed to certain design choices, it becomes really hard to change that. And like I will just use an example from my background. I have a PhD in electrical engineering, and I used to design processors and stuff like that. So
hardware guy, love it.
Yeah, exactly. So processors started like that. You have one processor, one ALU, arithmetic logic unit, that performs all the logic in order, right? And then like, we need to run more instructions, so you need more cores or need more ALUs. And now you start about, who will be executed first and how to enable parallel processing. And this required significant changes on the hardware level to be able to move to the parallel processing wallet. It doesn't happen like, let's put them together and they work together. It doesn't work like that at all. Yeah.
And changes at the software level. I mean, I remember when this happened, it was sort of the parallelization revolution. It was sort of like, all right, we now have to rewrite applications to start thinking in terms of, wait a minute, like this might be one application, but actually there are these multiple threads that we can do things in parallel, and then therefore we can get overall better throughput. So you have to like kind of think through the whole thing top to bottom.
Yes. So you have to kind of go back to the drawing board and start designing from scratch how to run the same function, but in parallel. And this is what I would say you at Radix and other protocols have done with different approaches as well. And that's the core discussion we're having. What are these approaches to do parallel processing? How they are different? How one way can beat the others in performance? But we are still in a very open field, and the crypto space as a whole is very early. So we will see over time which protocol prove to be more viable and more performant.
So maybe you could talk through sort of a couple of the approaches that you're seeing and sort of compare and contrast them.
Yeah, for sure. I would put them into two main buckets, and in each bucket you will have multiple candidates. The first bucket is that the differentiation between two buckets is how to identify actually independent transaction, because this is the main question. Once you figure out this main question, everything else becomes super easy. So
right. How do you know what things aren't related to other things? Yeah,
exactly. So one bucket is to ask the software or the smart contract or the developer to define which parts of the state. And what is the state? The state is the blockchain memory, the collection of all the accounts, all the assets on the blockchain. We call this memory like state. And transactions that are independent, like transactions in a computer, access different locations of the memory. I want this address of the memory, you want this address, we are not dependent. But if both of us want the same address in the memory or the same piece of the state, then we are dependent. One of us has to wait for the other. So the main question is how to identify which transaction have access to which part of the state. So the simple question is that, every transaction has to clearly state which part of the memory or which part of the state it needs access to. And that approach was first implemented on Solana, C-level execution environment. They created the account model, where everything in the state is an account. And every account, when this account has to create a transaction, it has to reference or point to the other accounts that it needs to use. I need to use this account. I need to use this account. and no one else can use this account while I'm using it. But anyone else who is using different accounts can go and run. So this was one approach. Actually, Sui is also following a similar approach. They use a different terminology though. They call it objects. So we have what we call as objects. And objects, instead of representing accounts, they represent assets. So actually, like Chao and Imran from the DeFi Alliance, like had a podcast with the founder of Sui, and he went through the details. But objects are assets. So if I'm handling an asset, I'm handling an NFT, sending it to another asset, to another person. Now we post reference the asset. So no one else can handle this asset while we are handling it. But anyone else can handle a different asset. So this is objects, right? And to some extent, Radix does that. Matt, you obviously know way better than Radix than me, but I think you call this resources. You define the assets as resources, but I will let you unpack this more. So this is one approach when you kind of ask the developer or ask the smart contract to define which state they are using.
And is that Sui approach, does this have similarities to the UTXO sort of model of state? Is there? I would
say so. Yeah, UTXO is kind of like a cash system. I give you a bill, you take this bill, you give me a change, which is essentially a different bill. You don't have an account where we can just add or subtract, right? The UTXO separates this by separating the mediums that we are exchanging. I give you something, you give me something else. We are not dealing with the same thing anymore.
So it's kind of like this object model. You can say like, these particular coins or whatever it is, these are the ones I'm going to be touching in this transaction. And so if you're not interfering with those, you're fine.
Yes. And according to the founders, their innovation or the main innovation is actually like in this data model, the object model that allow them to process more transactions. And I agree with them to some extent. So this is the first bucket in general, which is like, let's define what we are touching. The other way is, I would call it optimistic execution. And this is mainly adopted by Aptos, which is again, I'm a hardware guy. So if I use the terminology from the hardware world, it's called out of order execution, right? The developer can just spit all the transactions that they want to run or the assembly codes you want to run, and let the hardware figure it out. Let the hardware figure out which transaction is not dependent on the other. We can run all the transactions in parallel optimistically, assuming that none of them is dependent on the other. And if we figure out later that one of the transactions or one of the instructions were dependent on the previous ones, we just flush this out and repeat it. So optimistic execution is another approach. When you let the blockchain define all the transactions, you send this transaction to the validator runs them optimistically, and then during the execution, if one transaction depends on the previous transaction, this transaction is stopped, all the execution is flushed, and you repeat it with the new data that you have. In principle, this can be interesting and it can lead to significant improvement if everything is independent. But if some stuff is dependent, you end up paying some penalty. Like we have to stop, we have to repeat this transaction. And the penalty depends on how many or what is the percentage of transactions that are dependent in your payment.
This has been my understanding of the optimistic model is that, it has this, if you generally have a system where most things are independent, then it can do well. But if you have a situation like, let's take an AMM where we're doing an exchange for something and you want to push a bunch of transactions through that, you have this circumstance where it's not an optimistic situation because everyone's basically trying to access the same tokens in the same pools and trying to do this more or less the same thing. And so now, you can have this trade-off of kind of having a lockup circumstance where, the first transaction goes through, then the second transaction, it tries to follow that. Well, it can't be processed. So you either have to just reject it, say like, well, sorry, you were trying to do something and something else got in ahead of you, or you can do the retry. But then of course, retry gets a little weird because maybe you didn't want to retry it. Maybe you wanted to be like, no, I know what I want. And either that happens now or it doesn't happen. I don't want this happening an hour from now when maybe the market rate has changed and the price is different than I want. So it's like, it's an interesting trade-off balance.
Yeah, that's a good point, Matt. Like, because you obviously about like front running and MEV in Ethereum, and this exactly what happened. If your transaction didn't run at the moment that you want, someone else can actually interact with the same pool, change the price, and now when your transaction runs, you are getting a completely different price that what you intended for. So optimistic execution has its own plus and benefits, and there is a big body of research on what is the benefits. First, like I would say, the largest benefit of optimistic execution is that it pushes the problem to the validator and the validator implementation. It doesn't ask anything from the developer. The developer doesn't have to think about anything or develop anything further than what they originally do. It pushes the complexity somewhere else. It kind of hides it from the developer. And it can be a compromise or a trade-off that is worthy. We don't know yet.
We did some analysis of like public ledger uses, and we found on Ethereum that 95% of transactions, operations on ledger are actually interactions with smart contracts. That's actually not that surprising considering ERC20s are also smart contracts, right?
Yeah.
But 95%. However, the thing that we found surprising, or found surprising, is 75% of those are interacting with 3 or more smart contracts simultaneously. Which means that the level of dependency and interrelation of actions that people are taking on ledgers is really high. So if you want sort of optimistic execution, it's really not a very good way of building things for a composable ecosystem approach, which is actually what drives most of the volume in DeFi and most of the utility on public ledgers, if you just look at the sort of the fee usage by percentage of action. So yeah, I think optimistic is a naive, I mean, if you can say anything is a naive approach, because everything is to some extent naive because it's all being worked out for the first time, right? But like it feels like a particularly naive approach given the fact that you can look at what is actually being used on top of public ledgers and what the interactions expectations are, and then what problems that would emerge in terms of having to just continually reprocess transactions that are conflicting with each other.
I would agree to some extent with you that it's a naive, but like we cannot say it's naive as a blanket statement because your hardware, my phone, your laptop uses optimistic execution all the time. So like, and this is like a foundation. Like it's not out of realm of possibilities to use optimistic execution because sometimes you lack the context. You don't know what I'm accessing in the future. So you may say, okay, let's just take the dev and like run this transaction and see what happens. And I would say in general, at least in computing in general, optimistic execution or out of order execution gives a big advantage. And for existing systems, like for example, someone wanted to explore the possibility of restructuring the EVM to make it parallel. Can it be done? Yeah, they re-optimize the code, they did allow it parallel execution, and on average, they got 5x improvement. So if the Ethereum community decided tomorrow to adopt the concept of parallel execution, they will have to change the implementation of the EVM, and they can achieve something like 5x or 10x.
Did that 5x improvement include MEV? So was it simulating highly contentious transaction mempools?
Yeah.
Or were they simulating executed mempools? Because there's a big difference, right, in terms of what happens in the ordering before you execute versus what was actually executed. Because what you're actually executing isn't where most of the reordering happens. So I'd be really interested if it was run by replaying what actually happened, or if it also replayed the MEV aspect as well.
Yes, that's a really good point. I think I have to go back to this article to read it more, but like I think they just took some part of the transaction history in Ethereum and they just used it for testing. Which is
the easy bit. Yeah, that's the easy bit. It's already ordered. That's the easy bit. So that's not actually testing it. This is why I'm saying this is why I feel like it might be. I'm not going to say it is. It might be a naive implementation. That's all.
Yeah, and you brought a great point, Piers, when you spoke about composability, because, like you said, the average transaction deals with 3 contracts. I would argue, actually, because I try to do this analysis myself, I argue that like it may be even higher, because
I said
now
at least three,
at least, yeah,
75% deal with at least 3 smart contracts. Yeah.
I totally agree with this conclusion. Some transaction I see can handle 20 smart contracts, especially if you are trying to use a smart router for DeFi exchange or something, or an AMM.
Right.
That transaction
If you're using a DEX aggregator, right?
yeah,
You're using
exactly.
1-inch. Yeah.
Yeah, it will just from Uniswap to SushiSwap to whatever, and like you end up by, if you open the transaction and Ethernet scan, you can say, what? I didn't ask for 20 transactions to be done. Like I just asked it for one exchange.
Mm-hmm.
Mm-hmm.
So to not go too much in the weeds and in the sort of the problem space, it'd be great to, Matt, for you to sort of talk a little bit about our design philosophy in parallel execution and how we've sort of like architected that.
Yeah, it's interesting. I've got the advantage of coming after your wonderful overview of some of these approaches, because these were very similar questions that we had when we were going back to designing Scripto, designing our virtual machine, even designing aspects of our consensus protocol. It was like trying to think through, trying to resolve some of these problems. Like if you can clearly state your dependencies up front, then cool, you can get parallel execution. But then, like you said, you also don't want to be in the situation where the developer has to do a bunch of extra work and figure out what stuff they're trying to grab. Like so, and then we were also trying to balance, like you said, sort of the idea of like, optimistic execution is nice in some places, but then there are all these aspects where these places where you need to have serialized operation, like like the Cardano situation is a good example of this, where if you're explicitly nominating all these UTXOs, if you're saying individual coins that you're using to use in a trade through a swap, if everyone's trying to grab from that same pool, you're very likely to be trying to grab the same coins as somebody else, which means that most transactions actually fail. So we're like, okay, yeah, we need to allow these high contentious smart contracts to be fully serialized, but still have that serialization happen in parallel to everything else happening on the network. So yeah, this is exactly the problem we were trying to solve. And I guess the approach that we came to of this was a little bit of a hybrid of some of the things you talked about. It is definitely closer to some things than the other. But as you said, for one thing, we start with the idea of assets as being this sort of important fundamental thing that we've got. We have resources, and everything on the network is represented as these, everything of tokens and NFTs and all those sorts of things are all represented as resources. And so that allows us to build that into the design of the thing. Like this is what we're trying to parallelize in some sense, is the movement of these tokens. We're not forced into thinking about parallelizing smart contract calls to token smart contracts. It really changes the nature of it. But the other part of it is that alone didn't do it. Like we started with that, and like this asset-oriented approach was really our fundamental starting point. But we ran into this contention issue. We're like, okay, well, we thought maybe we could do this thing where every transaction says, okay, I'm going to be grabbing these tokens and doing these things with them. But it kind of has that UTXO problem like Cardano, where it's like, well, yeah, but you're going to naturally get contention when you're trying to go through serialized things. So the other piece of the puzzle that we had to solve was, what is the nature of our transaction? And we actually went through a bunch of iterations on this about like what goes into an actual transaction. What is it? And what we settled on was this thing that we haven't really publicly used this term, I guess, but you can think of it as intent-based transactions. The idea that the transaction says, here is what I want to happen in the end. And this is pretty important, because what it means is I'm not identifying individual resources. I'm not saying, okay, I've got an account that has 10 tokens in it, and these 2 tokens are the ones that I'm trading. Because as a developer or as a wallet user, I don't care. I just want 2 of those tokens, whichever 2 are available at that time. So why are you forcing me to put that into the transaction? But nonetheless, I can still say, here is what I want to have happen, what we need to translate that to is that the proposer of the transaction at the network level, so the node that is proposing at the network, it's kind of similar to the optimistic approach in that the proposer can deterministically say, for this intent, I can figure out which things on the network that needs to interact with. I can say like, okay, well, it's these tokens or these smart contracts or these accounts or whatever it is. I can put my hands on all those things and go, okay, I know which nodes I need to talk to get consensus on specifically those things. But I think the advantage of the model is that we actually are quite flexible about what those things are and what can be in contention. We can go all the way down to the level of resources. We could say like, okay, well, are these individual tokens in contention by any other transactions? Or we can push it to kind of the other extreme and say, well, actually, this smart contract, we treat that whole smart contract as one shard. And so we can serialize through that. We could say like, as long as you're not interacting with this smart contract, you're good. But if you are, so for example, if you have an AMM, if you're interacting with that AMM smart contract, it's got to be serialized. You're not going to be able to grab individual tokens out of there because it's going to become contentious. So we've got a lot of flexibility in defining how that works. And it allows us to even kind of break and unify these things to a certain extent. Like if it turns out there's something that needs to be more parallelized, or something that's like, it's safe to say, like, for example, if I'm depositing tokens to an account, that's obviously not going to be in contention with anything else in that account because I'm not trying to take anything from that account. So we can start building some of these more application level notions so you can make logical decisions about what is actually related or not. So but it required quite a deep approach. I mean, it required really, our transactions. I don't think there's anybody else in the space that's doing these sort of intent-oriented transactions, which also have the benefit of being able to be very composable, where I can say, okay, what I want to happen is these tokens leave my account, go into this smart contract, the result comes back. Now I put it in this other smart contract, that comes back, and the result gets deposited to my account. I can do that in the transaction, and the protocol can go off and say like, oh, okay, for all of that, I need this, and this shard, and run consensus on those things.
Yeah, like again, like when I read your design, it's very logical, and actually, like I like one important piece, the abstraction. For the intent-based transaction, you do this in the Radix engine, right? While for the details of how to execute and which shard the transaction has to pick, this is a consensus or Cerberus, right? So like this separation of functionalities actually allows you to do a lot more stuff. Like the developers will not care about what state I'm touching per se. I will just define an intent, and any transaction has to have an intent. Otherwise, it's not a transaction. You have to say, I need to do X. I need to change Ethereum to USDC or to wrapped Bitcoin, whatever, right? So the intent is high level and it has to be there. So you are not asking the developer to do anything additional. That's what they have to do anyway. And then,
all they need to think about is what they care about. Yeah.
And after that, you take this and you put it in a smart consensus engine, which will, these tokens are available. Let's use these resources instead of the other resources because these are available while the other have been already consumed by another transaction. So I think this also fits into another theme in the space that is very popular now, which is modular blockchain. When you try to separate the execution from consensus, from data availability. So I would say it's a smart design, but I'm not sure like how far are you in the like details of launching everything, and like because I know that you have two levels of Cerberus. Like one is like using one shard, one is using multiple shard.
Yeah. So I mean, the Babylon network, which is going to be our next release, where we have all the smart contract capability, it's single sharded, but it's still using basically the data model that we need for sharding once we introduce sharding. So it's basically like this intent-based transaction stuff is all going in, and that gives us the ability of starting to make some of these decisions about how we represent states, so that once we get to the point where it's like, okay, now we have a consensus model that is able to coordinate consensus across shards. Cool. Naturally, like you don't have to rebuild you don't have to rebuild applications. You don't have to, like you said, it's somewhat modular. Like the upper layer kind of doesn't need to know that the lower layer is sharded. However, the modular thing, it's an interesting point you bring up, because it's an important concept of understanding like what these different modules of the system do and what they're intended for, but you do have to have the interface down to the lower level. So for example, for us, if we completely abstracted the virtual machine notion from consensus, we might naively build the consensus part to go, well, we're just going to assume global ordering of everything. And if that's what your input looks like, is like, look, just tell me what's happening in order, then there's no way that the upper module gets what it needs to do, or no matter what you do at the upper level, you can't shard the lower level. So it's like, you use the term that I really like, which is layers of abstraction. And for people that aren't into programming, I don't know how familiar this is, but I can't tell you how many debates we have inside Radix about layers of abstraction and which ones are appropriate, because it is so important. It's like it's basically at every layer, every module of the system, it's defining what that module needs to do, but what interface it offers to the next level up. So it's sort of like, what tools do you have to use to interact with me? And so we always try to make it so that, when a developer is interacting with the system, they have interfaces that make sense to them. But then you can do a bunch of work under the hood to translate that into what the next layer in the system down needs to receive. And so as long as you kind of understand what those interfaces are, you can kind of have your cake and eat it too. You can kind of, allow people to work at the level they want, but also have pretty, bottom to top support for these features if you need to have combinations of serialization and parallelization, all this kind of stuff.
Yeah, totally agree. But actually, I discovered that until now we have been just focusing on the plus side of parallel execution, right? Like everything is beautiful with parallel execution, which is not true, right? And there is a price to pay, right? And this price to pay is actually another area of differentiation between different projects that are building in space. And for me, there are two big pieces that are largely unsolved until now. First is like when you have parallel transactions, great, you can run 100K transactions per second? Great. Who is the validator who have such a powerful machine or powerful server system to process 10,000 transactions per second or 100,000 transactions per second? And if they can, they must be investing a lot of money to build that, which will essentially lead to centralization, right? You can have 100 validators or whatever, but each one of these validators is a bank or is a big company or that can afford to have a data center to run these transactions, right? So parallel execution is great, but it has the one price.
There's an assumption there though, right? So I mean, that's true if you have a fixed number of validators. So if you've got 100 computers and they're trying to get stuff done, then, to kind of take the simple case, if it's serialized, it's like, great, all 100 have to agree on everything in order and it's kind of inefficient. So it's like, all right, let's start introducing parallelization. Cool. Now each one of those nodes can be processing multiple things at once. So you kind of remove that bottleneck. But the assumption here, but I guess once you start parallelizing things, once you start saying, well, these things can be processed and it doesn't have to know about these other things, doesn't that also allow you to expand the number of nodes that you have? So say I can have a node that doesn't even have to pay attention to a bunch of stuff that all these other nodes are doing.
100%. And that's why the devil is in the detail. It depends on how you implemented that, right? How exactly you implement your parallel execution. And can you use the same parallel execution concept to split validators or network block producers into different blocks, different groups. Right. You handle this piece, you handle this piece, and we don't have to interact. Maybe in a few minutes we have to interact when one of my transactions are touching yours, something like that.
Right.
But so far, not the only, I would say, production ready parallel execution network now is Solana. So this is Aptos has just launched. We don't know how it works at a massive scale yet. So we will be launching soon. So Solana.
Oh, I see. And Solana takes the approach you were talking about, right? Solana takes the approach of saying, all right, we're gonna process these things as parable, but basically it's going to be this fixed set of computers that's trying to process all of this stuff in parallel, which is why Solana nodes are really heavyweight and so forth, right?
Exactly. So the major differentiation of all the players that are coming to market, including Radix, is that we are not just doing parallel execution or separating independent transactions. We are also separating independent states. Every group of validators will handle different bit of the state. So, and this will allow someone like me to have my laptop in my basement and like run some validation on the network to make it decentralized more, instead of just we having 50 entities or 100 entities owning everything and controlling the network. So this is a strong different, back to our point, how parallel processing approaches differ between each other. I would say this is more of an implementation detail, but that's very important because it touches on decentralization. If you don't think about it, you will end up by a centralized network. So what did we do? We had Google already and we had Facebook already. So we didn't need a new Google or a new Facebook. So
yeah, and sometimes it's hard for people to understand the differentiation. When you say an implementation detail, it's like, in some sense, consensus kind of doesn't care, but the users of the network deeply care, even though it's like you could have implemented the same consensus approach in both ways and it wouldn't have really changed anything. But that choice you make really impacts the level of decentralization and even the level of actual throughput. Like Radix is very definitely going in the direction of basically more nodes, less node, and each node doing less. Because from our point of view, this is what gets you to linear scalability, whereby if you want to process more transactions, you add more nodes to the network rather than you have to add, an unbounded amount of computing hardware, which obviously at any given time, there's kind of a fixed amount of computing hardware. So that's definitely the approach that we took of this. But like you said, it's sort of an implementation detail, but it has a cost as well. So this gets like what you're saying, like, the cost of us doing this approach across multiple computers means that now you have to be a little bit more, like now you have different nodes on the internet that are holding different parts of the state. And so there's a little bit more coordination you have to do to make sure that, the right thing is involved at the right time. Yeah.
And that's why it hasn't happened so far. Like everyone, it's easier for Mood to push the complexity to validator, get a huge server to run to validate on the network. And it's because someone has to handle this complexity. If the developing team of the blockchain decided to handle this complexity, then they have to think really to the nitty details about how we can coordinate that every validator maintains their state, their part of the state, and don't disappear with it, right? And how to coordinate, they can exchange sub-states when they need to, efficiently with short latency or short finality time. So there is a lot of complexity. And I hope to see someone really succeed. I hope you at Radix succeed to implement this detail, because it's a really difficult design, and whoever wins it will be in a really great position to win a big section of the market. The other part, I'm not sure if you have thought about it or not, in parallel processing is that the data. Now you process this much transaction and you have the state and have your archive. This archive has been growing exponentially, I would say, right? Especially for networks that have been already in production. And this is a problem that I don't have an answer to. So maybe we can use your expert's math to answer it. How can you handle actually the bloat, the state bloat, or how to reduce not just the archival memory, archival state of the blockchain, but even the bloat of the state itself. When you have millions of accounts and millions of assets, and the state itself gets bigger and bigger. Yeah, you may have an advantage of splitting the state between different validator groups, but the archival issue is still there.
Yeah. It's an implementation detail. That's no big deal. That's
Okay, that's
no. But you're right. It's a huge implementation detail. Yeah. It's another one of those choices. I mean, yeah, exactly. This is one of these things that, I wouldn't say that there's nothing really necessarily about Cerberus or what we're doing that sort of is specifically addressing the state bloat problem. It's kind of a generalized problem. But I think that, I think there is I guess there's kind of two layers of it from my point of view. One layer of it is just a kind of a bulk storage problem. If we just assume it's look, blockchains are going to be producing this history, that history creates a lot of data. Where's all that data going to live? And it's kind of it's in some ways, it's sort of like the trade-off you're talking about in terms of how do you do the parallelization? You can go to the Solana approach, which is basically all right, really high performance stuff is trying to handle all of this in kind of one place in an efficient way. And the data model kind of goes with that. It's sort of well, not only do these things need to have really high processing capacity, they also need to have really large storage capacity because they need all of that state to be able to do all their work. The other approach, again, it kind of goes together. The approach that we're taking is we fragment it. We say, no, we allow an unlimited number of nodes to process things in parallel. And from a similar point of view, an unlimited nodes can hold increasingly more fragmented parts of the state. So, I mean, and you have to distribute that. So it's not like one node has one state, and if they go offline, that data is lost forever. Yeah. There's always overlap in a lot of these things, so that, basically we think of it in terms of shard space. So if you imagine that this total set of all the possible shards that could probably exist, you need to make sure that you're distributing all of your physical nodes across that shard space, both to process stuff as well as to store that part of the state that they need to do that consensus on the stuff. So, I mean, at a first level, we feel like that's a good solution to the problem, because it means that as the network becomes more popular, it basically naturally becomes more fragmented. And so if I'm running a node here and I've got a certain limited amount of processing capacity and storage, basically what happens is over time, my slice of shard space starts getting narrower and narrower because there's more demand for the network, more transactions being processed and so forth. So that's one layer. I think the other part of this solution, again, this is not specific to Radix really, but I think there are some really interesting techniques out there for kind of collapsing history down. Because the reason why we need history, for the most part, is to be able to prove that what's happening now is correct. And so, the most straightforward thing is like, well, you keep a complete transaction history of everything that's happened, and therefore I can walk back through that and see that what's happening right now is actually valid. That's kind of, where Bitcoin, that's where the blockchain.
I think you're referring to Mina, which is like using ZK proofs, or zero-knowledge proofs,
right,
to prove the history
exactly
of all the, the blockchain is valid since the beginning, and we only keep maybe a few kilobytes of archive, but everything is proven, so you don't have to worry about it. We can just prune it or delete it. Yeah,
exactly. That's one of the techniques. Yeah, exactly. And I think there's there's a balance here, because you also kind of need the history just because you want to be able to see what happened and so forth. But in some ways, you can start pushing that to separate indexing layers. Like we have this concept called a gateway that kind of does this. It basically is just consuming data from the network and is offering that history to people as kind of, it moves it outside the blockchain space. It just becomes a traditional database that can serve data up. But what you really need for consensus is, like you said, you can collapse this down with ZK proofs and other techniques so that any given node performing consensus can know, yes, I can vote yes on this transaction because I have the right proof that, and maybe you snapshot every week or whatever you think makes sense. So, we don't have that implemented in Radix, but it's something like, as we become more popular, I expect that those sorts of techniques get introduced. It's just an implementation detail.
Perfect. I'm looking forward to see the Babylon network and like the following steps of Radix. Like, I see that you are working in a really great concept, but like it's a ton of work, and like my heart with you to handling all this complexity. So.
Mm-hmm. Yeah.
I mean, there's sort of advantages and disadvantages in doing it, right? The clear advantage is that we have been able to look at what other people have done and what the approaches have been done, and as a result of that, identify the things that were not known as issues in architecture decisions, and then make better architecture decisions as a result of those decisions that were made. Now, but obviously, as the space grows bigger, maybe some of those architecture decisions will turn out to be wrong, because you never know what the future holds. I think that from a purely logical perspective, going down the route of saying the network is increasingly sharded, as in like fragmented, I should say. On Radix, actually, the shard space is fixed. So it's 2 to the power 256 shards. It's always 2 to the power 256 shards, but the network becomes increasingly fragmented as the amount of data and processing increases on the network, so that you're able to horizontally scale the network. I think that logically feels like the right direction based on the advantages of horizontal scaling versus the disadvantages of vertical scaling, right? But then the disadvantage of doing this sort of full stack approach, where we are able to design each layer of the stack to work more homogeneously with the other, is that it does change the developer paradigm. It does change the sort of like the network infrastructure paradigm. And so like getting infrastructure provided up the curve on that, getting developers familiar with how you build with our programming language, getting sort of like users familiar with what the interface experience is versus something like MetaMask. Actually, I think that's the easiest thing because MetaMask is awful, but like that's the thing that's the most difficult. Like our bet here is essentially that making the right choices at an architecture level means that you aren't bottled by you don't have bottlenecks to your success later, which is basically what most of the decisions we're seeing in the space essentially do. It kicks the can down the road, doesn't really change the end state. By making radical decisions on how you create a developer experience more secure and more easy, you are throwing away Solidity and the EVM and all of this sort of like existing infrastructure that people have built over the years. But as a result, you make it far easier for new Web3 developers to come into the space. So you're taking a bet of the future of this space being much larger than the present, and that the dependencies of the future technology don't have that much bearance on the present, because what's been built in the present is basically a proof of concept. Like that's the bet here, right? That rebuilding the way you build to make it easier for developers to come into the space is a better long-term decision than copy and pasting what already exists and trying to improve on that, right? And then that extends all the way to the user experience layer. And so Radix is a radical approach from that point of view. But, you know, we think that radical approach is actually what's necessary to make the industry suck less than it does at the moment for users, for developers, and for people who are deploying on top of the ledger. So that's our bet, right? It's a big bet. It's an audacious bet. But like you got to make it big and audacious. Otherwise, what's the point?
I agree with that. You have to take some risks to hoping for a big reward at the end. So.
Right. Mohamed, it's been such a pleasure talking with you. Matthew, thank you so much for coming on and being the foil to this discussion.
Thanks for inviting me. This was fun. I want to do more of these. These are good.
We'll find more people for you to discuss with. Yes. And Mohamed, if people want to find out more about your research or Alliance DAO, where should they go?
Yeah, we are looking always to work with founders building in the space. We are very deep in the space. We have an amazing team. So looking forward to seeing more builders and more people coming to the space. And follow me on Twitter and on Medium. I always publish my work there.
So what's your Twitter handle?
It's Mohamed F. Fouda. Mohamed, very simple handle. So, and on Medium, it's Fouda directly on Medium.
Okay. And that's Fouda, Mohamed, yes. Fouda. And Alliance DAO is alliance.xyz, right?
Yes. And that, we are running the next cohort on Alliance DAO is next year. The application deadline is January. So if we are I will use your platform to encourage applicants or founders to apply to the Alliance DAO cohort.
Yeah, and when you guys start supporting Radix, we'll be sure to send you plenty of people.
Yep. Yeah. We will we don't actually we have of course partnerships with blockchains, but we are always looking for smart founders who are actually passionate about the space and want to stick in the long term. So that is our vision and mission in the space.
Awesome. I love hearing people say things like that in the space. It's really invested in the long-term potential of what all this means.
Yeah, everyone in the team essentially has been in the space for at least 6-7 years. So we have we ourselves are very committed. So we can it kind of shows. If you are in the space, you want people who have the same kind of conviction.
Awesome. All right. Thank you very much, Mohamed. And we'll speak to you again soon.
Thank you.
You better call on these guys. I'm going radical. I'm going Radix. I'm going radical. I'm going Radix. Hyperspeed DeFi, never on a decline. Building the future, I feel like a savage.